Welcome back, ladies and gentlemen. How do we find the green area? Now, the best approach to this problem is by applying the Euclid's geometry. Now, in Euclid's geometry, we had the Menelaus approach. Is the simplest and easiest trick to determine the green area if you don't employ the concept of congruence. Now, let us start by labeling this diagram. We can say this triangle to be triangle ABC, and the transverse, the first transverse to be AX, and this transverse line to be BY. Now, to apply the Euclid geometry, we shall use the Menelaus approach, whereby we shall be dealing with the areas above or below the transverse. Now, if you check the transverse line AX, if you take the transverse line AX, above it we have the area 3 and the unknown area, and below it we have 12 and 24. So you can see the areas below the transverse line are all known. So we stick to the regions where we have the known areas. So taking the transverse line AX, the areas below it we can denote by A, which is equals to 12 plus 24. And that gives you 36. Then if you take the transverse line BY, then the area below the transverse line BY, if we denote it by B, then it is 3 plus 12. So 3 plus 12 gives you a total of 15. Then we are now going to take the area below both of them. So if you take both the transverse line AX and BY, AX and BY, the intersection of the both transverse line is an area of 12. So below them we have an area of 12. So the intersection, we can denote that by C. So we have C is 12 is the intersection of the two transverse line. Below it we have an area of 12. Now if you employ the Menelaus approach, the area of this entire region ABC, if we denote it by A, then the ratio of the area 1 over area will be equals to the ratio 1 over the first area below the first transverse line was A, then plus the ratio 1 over the area below the second transverse line we denoted by B. Then you can see the intersection of the two transverse lines. You can see 12 is in below the transverse line AX. At the same time, 12 is below the transverse line BX, which means this is a common region of an area of 12. So it has been added twice. So for you to get that ratio of the area, you subtract the intersection, the ratio of the intersection, which is 1 over C. So if you do the substitution, we have 1 over area is equals to 1 over A, and A we found is 36. Then it is plus 1 over B, and B we found to be 15. Then it is minus 1 over C, and C we found to be 12. So what do we get to be 1 over A? 1 over 36 plus 1 over 15 minus 1 over 12 will give you 1 over 90. So if you cross multiply that, you will get the area to be equals to 90. So the Menelaus approach of the Euclidean geometry is actually the best means to determine the area of this entire region, or the triangle ABC. So once you found the area of the entire region triangle ABC, then the area of the green region, which is unknown, is the area of the whole region minus the known areas, which is 3 plus 12 plus 24. So if you add 3 plus 12 plus 24, you'll get a total of 39. So 90 minus 39 will give you the area of the remaining region, which is 51. So the area of the green region is 51. Ladies and gentlemen, that is the Menelaus approach of the Antiquity period before Jesus Christ. That was the simplest means to handle Euclid's geometry if you don't apply the method of congruence. If you have any other means of handling modern geometry, don't forget to leave it in the comment section. Thank you for watching and see you again in our next presentation.